Electric vehicles. The amount of electric vehicles on the road has been rapidly increasing here in California. Some of us may have noticed more of these electric cars slowly popping up on roads. And, as we can see here, it is true that there are in fact more electric cars being used. If we look back at the year 2020, which was a major year when EV sales took off, in this data sheet from the California Energy Commission, you can see the total sales of BEV or battery electric vehicles was at 85,000. We will just look at this number of BEV sales for simplicity, but now let's jump to the current data from 2025. That number has since changed to 275,000, which is a 320% increase from the year 2020, which was a 5-year span of time. As more people get electric cars, we need more chargers for them. Those chargers pull tremendous amounts of power from the grid, and that will become a bigger problem than it already is today. So, in this video, we'll look at how adding solar power to EV chargers could help aid this problem. My name is Josh, and alongside me I have my colleagues Emily, Ashley, and Wyatt, and we will be talking all about the science you need to know about this solution. Things like how grid power is used for EVs, how solar panels work, how to store solar energy, and how to effectively and efficiently use solar energy.
Let's first take a look at how the grid works. The grid gets its power from various sources such as fossil fuels, nuclear power, and renewable resources. Then that power is converted from AC power into DC power the vehicle to use. All EV chargers are connected to the grid, although we are aiming to reduce the energy taken from them, as these EV chargers create a large stress on the grid, as it's mentioned multiple in an article from Dr. Jonathan Snodgrass and a team of researchers from Texas A&M. Some quotes: if everyone got an electric vehicle, it would be more or less double the usage of the grid, and that's a big deal. When a user plugs their car in for the night, the car starts charging immediately, which adds strain on the grid, since the grid usually has its highest load between 4 to 7 p.m. Imagine several people pull up at the same time. A megawatt of load would be added to the power grid, and almost immediately, and the frequency of the grid would fluctuate because the balance between electricity supply and demand is off. So to aid the demand, we'll add solar shades or canopies, as it's called, to produce 16 EV chargers. These EV chargers will use all the energy possible that generated from the solar panels and only draw from the grid when necessary.
Although, why are we using solar panels specifically to aid this power demand? According to one of Energy Save's articles, it talks about how solar power helps reduce electricity demand, ease stress on the grid and transmission system, and lower costs for consumers, especially during peak usage time. As it states, solar helps the grid, offsetting the need for spending on both generation and transmission upgrades, and add up to real savings for all consumers on the electricity grid. Specifically, it states how installing solar helps reduce the need for producing and procuring electricity, which reduces the amount of electricity that needs to be moved across transmission and distribution lines. So, if we're implementing solar panels, let's take a look at how these solar panels work. Solar panels work through something called the photovoltaic effect. The photovoltaic effect is where photons from sunlight knock electrons free from atoms, which then create a flow of electrons that generate electricity. You can also find this information from the Department of Energy and National Grid Group.
To effectively harness the energy from the solar panels to be used as a charger, this would require having some sort of battery or energy storage system. The battery is wired in the solar panel system to store excess energy that the solar panel receives instead of sending it back to the grid or going to waste. The battery will be able to store about 25 kilowatts to 100 kilowatts of energy. Once the excess energy is stored in the battery, it can be used whenever. The battery will greatly help with the solar panel EV chargers because the sun won't be out for many hours, and people will need to charge the cars at later times. The battery will allow them to charge them during later hours, all while supplying them with enough kilowatts. The article Aurora goes deeper into this information in regards to these batteries for solar panels. Although using this battery alone would not properly work, the battery might discharge into the solar panels during the night. This is why it requires a solar controller. A solar controller is a voltage and current regulator that sits between the solar panels and solar battery. This helps to protect the batteries from overcharging and prevent the battery from discharging into the solar panel when there is no solar power generated, which could cause permanent damage. This in turn will allow the solar panel EV charger to work smoothly without causing any damages to the solar panels or the cars. This has been the main scientific component of our system of implementing solar-assisted EV charging. Thank you for listening.